A 6 GB model just ate 70 GB of VRAM on Ollama, and if you don't know the fix, every local LLM session you run is wasting your hardware. Ollama just pushed updates claiming to fix these problems, so I'm testing its 5 boldest claims right now to see which ones actually hold up. And the part that's going to surprise you, the $20 Pro plan might be completely unverifiable as a value, and I'll show you exactly why when we get to claim 3. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. And every number in this video traces back to official Ollama docs or community benchmarks people actually ran. If you're running local LLMs on a 16 GB GPU or an Apple Silicon Mac, these claims decide whether Ollama's worth your time or your money. Claim 1, Ollama fixed the RAM problem. Here's the failure mode. You load a 7 billion parameter model expecting maybe 6 GB of VRAM, and instead you watch your system grind to a halt because Ollama silently pre-allocated a 65 GB KV cache, your session crashes, your GPU is maxed, and nothing in the UI told you this was happening. What I found was pretty interesting. A community tester loaded Qwen 2.5VL.7b with a 131K context window, and it ate 70.8 GB of VRAM, with 65 GB of that being just the KV cache. And the official Ollama docs confirmed that on hardware under 24 GB VRAM, the default context is only 4K tokens, which is way too small for agents or coding tasks. But dropping context to 4096 via NUM ATX recovered 56 GB credit with 0 quality loss. So this one is partially true. The fix works. Lowering NUM CTX to 4096 genuinely gets you back 56 GB of VRAM. But I thought this would be automatic after the update, and it's not. You have to create a derived model and set it manually, which is a real extra step most beginners won't know about. So 1 claim in, and we're at 0, fully verified so far. Claim 2, 16 GB of VRAM is enough to run serious models. A lot of people push back on this one because 16 GB sounds like it barely runs anything useful. But the number that actually matters here is 139 tokens per second on a 20 billion parameter model sitting fully on an RTX 4080. And if that holds up, a mid-range GPU from 2 years ago becomes a genuinely capable local AI machine without spending more money. On an RTX 4080 16 GB running Ollama 0.17.7, GPT OSS 20B hit 139.93 tokens per second at 100% GPU. That's fast and real. And the same setup also runs Gemma 3 27B, Qwen 3 32B, and DeepSeek R1 to 32B at cool 4 km quantization. But load GPT OS 120B, which doesn't fit in 16 GB, and you drop to 12.64 tokens per second with 78% of the work pushed onto CPU. And that's an 11 times speed drop. This claim delivers, but only when the model fits entirely in VRAM. And honestly, 139 TOCOS on a mid-range card is genuinely good. So keep models at 22 to 35 billion parameters at Q44 km, and you're fine. And that puts us at 1 claim fully holding up now, 1 partial. Claim 3, Ollama Pro at $20 a month is worth it versus paying per token. For a solo dev running coding sessions every day, the question is real. $20 flat sounds like a deal if you'd normally spend $25 to $100 on API calls. But Ollama Cloud charges you in GPU time, not tokens, and there's no published conversion rate anywhere, so you can't actually do the math before you pay. What I found, and I couldn't find a dollar per level mapping anywhere, is that Pro is $20 a month, Max is $100 a month. Usage is split into 4 levels from light GPT OSS, 20B, tasks up to heavy DeepSeek V4 Pro. Session limits reset every 5 hours. Weekly limits reset every 7 days, but there's no fixed token cap to compare against API pricing, which makes the $25 to $100 equivalent claim completely unverifiable without knowing your exact usage pattern. Now, to be fair, if you're a heavy user running big models all day, $20 flat might actually be a steal compared to per token API costs, and the GPU time model could work in your favor, depending on session length and model size. But the real gap is transparency. You can't know before you commit. And that's a problem regardless of whether the deal itself is good. This one comes back unverifiable, not false, just impossible to score. and I went looking for at least a rough token equivalent published somewhere. But I couldn't find it. So the pricing structure exists, the usage tiers exist, but the math to compare against API costs simply isn't there, which means we're at one claim fully verified, one partial, one unverifiable after 3 tests. All right, so we've still got Apple Silicon and the frictionless claim left, and those two are where things get really interesting. One of them might actually flip how you think about buying hardware for local AI, and the other could change whether you even bother with Ollama long term. So don't skip out, because the next 2 tests are the ones that actually decide your setup. Claim 4, Apple Silicon gives you a real speed advantage with Ollama. The number that matters here is 112 tokens per second decode on an M5 running a 35 billion parameter model. And if that's real, a MacBook Pro becomes a serious local AI machine. And the unified memory story means a 32 GB M2. Mac can load models that would need a $1,500 discrete GPU on a Windows box. The vendor reports M5 with MLX hitting 1810 tokens per second prefill and 112 token SSD code on QN 3.5 per 35B A3B. The decode number is real and fast. And a 32 GB M2 MacBook Pro can use all 32 GB for model weights, which is roughly equivalent to an RTX 3090 or 4090. But the caveat I want to flag is that Ollama can silently fall back to CPU on Mac if it's misconfigured, and you'd never know without running Ollama PS to check your processor split. Apple Silicon delivers. I thought the unified memory advantage was a bit overhyped going in, but 112 TOC on a 35B model from a laptop chip is pretty hard to argue with. The MLX acceleration is real. The 32 GB M2 genuinely competes with top-end discrete GPUs for model loading. Just always check Ollama PS because CPU fallback is a real trap. And that puts us at 2 claims fully verified, 1 partial, 1 unverifiable. Claim 5, Ollama is frictionless and sustainable for ongoing use. The objection a lot of people already have is this: sure, it's easy to install, but how does it hold up when you actually need it to run fast and reliably day after day? Because if it's slower than llama.cpp, has a 4K default context, and can't handle multiple requests at once, then easy setup is just a pretty front door on a house you can't really live in. The install story is genuinely true. 1 command, model pull, run, and I can't knock that. But community benchmarks show Ollama runs slower than llama.cpp directly and hides the performance settings that would let you fix it. There's no continuous batching. The default context is 4K tokens. It's CLI only with no library support. And there's no SLA, so for sustained throughput or any kind of production workload, the alternatives are just better. This claim falls short. The frictionless part is real, and nobody disputes that Ollama is the easiest on-ramp. But sustainable is where it breaks down, and the community data says it's slower than llama.cpp with no way to tune it. So final tally. 2 claims fully hold up, 2 fall short or partially true, 1 unverifiable. Okay, so here's where Ollama genuinely shines. On a 16 GB GPU, GPT OSS 20B hits 139.93 tokens per second at 100% GPU, and 16 GB is actually enough for 22 to 35 billion parameter models at Q4KM. And on Apple Silicon, the M5 with MLX hits 112 TOCA decode on a 35B model, while a 32 GB M2 Mac loads models that would need a top-end discrete GPU on Windows. And the 1 command install is genuinely the best on-ramp in the category. Now here's where Ollama falls short, and I'm not going to soften this. The RAM fix is not automatic. A 6 GB model can eat 70 GB of VRAM via KV cache pre-allocation until you manually set numCTX, and most users won't know to do that. CPU offloading kills speed with GPT-OS RNE-20B, dropping to 12.64 TOCA-S, which is 11 times slower than full GPU, and for production it's slower than llama.cp, with 4K default context, no continuous batching, CLI only, and no SLA. 2 out of 5 claims fully holding up is a pretty honest result, and here's the decision rule. If you're tinkering on a 16 GB GPU or an Apple Silicon Mac, Ollama is worth it. Just set numCTX and run Ollama PS. But if you need sustained throughput or production stability, skip it and go llama.cpp or VLLM instead. because one wrong config and a 6GB model eats 70 GB. So know the fix before you start. If you want to see how Ollama stacks up against a paid coding agent on real tasks, I ran a full test in the video called Ollama versus Claude Code, Can-Free Local Keep Up. It's right up on screen now, and the speed gap there is way more interesting than I expected.